Recapping, for vertical angular misalignment, use the calipers to measure differential between top and bottom measurement. And for what they call the parallel vertical alignment, use a straight edge across and feeler gauge on top and also bottom. Sometimes a little difficult to get the bottom, but it can be gotten. And for the parallel, 0.015 is usually the standard of excellence, so to speak. That's assuming the lovejoys are the same size. Now quickly, what I prefer to do rather than text is just flat out take the caliper, measure the diameters, and that will give you a difference in diameters, which will allow you for any different misalignment. But overall, if you can slide if you cannot slide a 0.015 feeler underneath either, you are within acceptable limits. The next thing to go through is the other side, which is side. 90 degrees there with that same marking, and all the way to back where I am to my belt, so to speak, is a 270 mark. We do the exact same measurements there. So for the angular, which you always do the angular first, I align, take a reading, and according to my caliper, pressing in, I'm at 2.504 inches. When I rotate to the 270 degree mark, I do the same measurement, back off, and I'm at 2.496 inches. Now while that's within the acceptable limit, we can line up a little better. Notice that the longer measurement was in the front, the shorter in the back, which means they're more like this, pointed towards the camera. We need to move the devices back this way. In order to do that, what we normally do is loosen the bolt slightly on the motor mount and bump it to swing it more in alignment. Now, in swinging in alignment, we actually want to move the motor more like both the front and back bolts over. Since it's longer in the front here, we actually want to move this back, rotate the back out towards the camera, and even the side slightly towards the camera on an angle so that we can bring it kind of more or less in alignment. This is more like a bump is what it winds up being. So what we have to do is loosen our bolts. And we go ahead and loosen them. And again, you still want to keep it at least finger tight, I would say. And once you have them finger tight, then it's literally bump, possibly with your hand, usually is good enough in this case. And I'm doing my hand in the back of the motor here. If you want to hit with a hammer, only do the motor mount and not the housing. You'll bend the housing up, far worse. Frankly, I find for fractional horsepower motors like this, you really don't need a hammer. Use the base of your palm, it doesn't hurt there, and bump. It's bump on the housing even, that will do it. Tighten down these bolts. I'm getting it from underneath the table here. You want to tighten all four of them down again. And when we got them down, then we go back through the lovejoy, because this should not affect the vertical if all we're doing is just sliding the motor around. The bed plates are usually stable enough and flat enough that we won't really affect it. Now I go through a measurement, and this time I'm a little tighter. I'm at 2.499 inches. Actually, I need to rotate over around here, correct myself. And it is 0.2499 inches. And on this side, I go through, get it up, and I'm at 2.496 inches. So I'm well within a 0.010 inch. Actually, 0.035 is what's necessary. So the angular alignment is fine. Notice I keep adjusting the motor position and not the driven. The driven usually is a fixed item. Despite it's very easy to maneuver here, we don't want to do that because in practice this usually is a long chain that had to be aligned up. Far easier to do the tail end, which is the motor. Of course, the last thing to do now, a quick estimate on the motor for the parallel alignment is to go locate our marking again, put it on the side, straight edge it, take our 0.015, see if it can go in either side. It does not. Rotate to this side, Do the same thing. See if I can jam the .015 inch. And it meets a lot of resistance, so it doesn't jam in either way. If it does that, then we are aligned. Now this motor mount is finally ready to go. We have aligned it vertically, horizontally. We've leveled the motor beforehand. The shaft presumably was already leveled. It's all ready to go. In fact, pretty easy to turn. If I grab the motor with my 2 fingers, easily turn. Grab the shaft with 2 fingers, easily turn. This is exactly how a motor should be. Very little resistance. We don't want the bearings to be worn out, and we want as much of the torque in the motor to go into the shaft and turn the shaft as much as possible. Any resistance is lost work.